So thermophysics assignment, I have discussed the 17 questions from this. So question 18. In question 18, in the question, like while underwater, a diver releases an air bubble which is having a volume of 6.5 exponent minus 8. So that's the volume is given, which is 6.5 into 10 to the power 8. At a pressure, the pressure is 8.55 exponent 5 Pascal, and the temperature should always be in Kelvin whenever you're substituting in the formula. So to convert degree centigrade into Kelvin, we'll add 273. So it will become 278 Kelvin. The bubble rises to a surface where the temperature changes to 20. So the new temperature in Kelvin at 273, so it will be 293. As a bubble rises, the mass of air in the bubble remain constant. So mass does not change. Calculate the volume of bubble as it reaches the surface. Assume that air behave like an ideal gas. And the atmospheric pressure, so this is the initial volume. This one, when it was released at the bottom. So initial pressure is there, initial volume, initial temperature. When it reaches the surface, there will be a new pressure, new volume, and new temperature. So when all the three parameters are changing, so we can use a general gas equation. Like we can use PV is equals to nRT, or we can also use P1, V1 over T1 equals P2, V2 over T2. When all three parameters are changing, like pressure, volume, and temperature, then the product of a pressure and volume divided by temperature is equals to the product of pressure, volume divided by temperature. So P1, V1 over T1 equals P2, V2 over T2. Or you can also solve like using PV is equals to nRT or PV is equals to nKT, and just work out the first the value for the volume. So, but whenever all three parameters are changing, then the formula P1 V1 over T1 equals P2 V2 over T2. So P1 is the first pressure. We have the first pressure. This one is the first pressure. V1 is the first volume. T1, this is the first temperature T1. The final temperature T2, the final pressure is P2. So we just substitute and work out the final volume, which is V2. The next part, we just have to substitute the value. Explain why actual volume of a bubble as it reaches the surface will be less than the volume which we calculated. So what might be the reason for that? Why the actual volume will be smaller than, because we took the temperature of the surrounding. Like example, say we did not take the temperature of the bubble, we took a temperature of the surrounding. Like when it reaches the top, the temperature was 20. When it was at the bottom, the temperature was 5. This temperature is surrounding, but in practical, this air bubble may not have the same temperature as a surrounding. It might have a different temperature. It might have a low temperature. So the air bubble and the surrounding temperature are not same. That's why the volume won't be same. And it will be lower than, or what else might happen? The number of the particles might change as well. Like when we release the bubble, say there were 5 particles. But when it reaches the top, the number of some of the particles some of air is still dissolved. So number of the particle reduced. That's why its volume won't be same. So you can mention in terms of temperature. You can mention in terms of the dissolving the volume.